Good day, welcome back. I've got video 8 lined up for you of trigonometry working with identities and how to apply your double angles in this instance. Our problem that we're dealing with, they give us cos of 52 degrees is equal to tan, determined in simplest form in terms of t. Without the use of the calculator, a few expressions that we need to solve. The first thing that we notice is that t is not in a ratio form. So we need to write it as t over something. And that something in this instance is 1. So cos being a x value over r value will give me that I need to find my y value. I use Pythagoras and solve for y. I calculate my y value and I find that y is equal to 1 minus t squared. I populate the information in my sketch that the adjacent side is equal to t, the hypotenuse is 1, my y value is then 1 minus t squared. I also take the liberty to populate the complementary angle of 52, which is 38 in this case. Because at this level, they can ask me questions related to that specific angle. Our first question that they ask us, calculate sine of negative 52. The first thing I will do in this case is write this out using the rules. The rules state that sine of a negative angle is equal to negative sine of that particular angle. I notice 52 degrees is in the first quadrant. Negative 52 will definitely be in the fourth quadrant. So sine must be negative in the fourth quadrant. We all know that. So then I apply my rules. Negative sine 52. What is sine of 52 degrees? Sine is the opposite side over the hypotenuse, which is 1. So I write my answer as negative into square root of 1 minus t squared over 1. That gives me an answer of negative square root of 1 minus t squared. Our next question asks us to solve cos of 90 degrees minus 52. Now, if you know what this is all about, you will know that here they are talking about the complementary angle. Let's use the rules of reduction. So when I use the rules of reduction, cos of 90 degrees minus 52 will be in the first quadrant. So the name will change to sine of 52 degrees. What is sine of 52 degrees? The square root of 1 minus t squared over 1. So that answer is 1, the square root of 1 minus t squared. Alternatively, I could have done this sum also differently. I could have answered it from the sketch, and 90 minus 52 is actually the 38 degree angle. So if I've written 90 minus 52 is equal to 38, so cos of 38 degrees, there's 38 degrees, cos is the adjacent side over the hypotenuse. So square root of 1 minus t squared over 1 gives me the same answer as sine of 52 degrees. Our next question asks us cos of 19 degrees. Now, in this sum, there is no 19 degrees. But I know something. There's a relationship between 19 degrees and 38 degrees. 19 is 2 times is 2 times 19 is equal to 38. So, in this instance, I will start making equations. I will say, in order to solve cos of 19, I will say cos 2 times 19 is equal to cos of 38 degrees. At this point in time, I know that cos of 38 degrees is equal to that side over that side. So, I will use this equation to solve my problem. Right? So, the first thing we do, this will be cos squared of 19 degrees minus 1. 2 cos squared of 19 degrees minus 1. Now, if I work with equations, I will try to isolate the 19 that I want. So firstly, I remove whatever is furthest away from the 19. So minus 1, add 1 on both sides. But remember the value of cos 38 was square root of 1 minus t squared. I write that down. I add 1 on the left hand side, I add 1 on the right hand side. Minus 1 is gone. Next step, I need to divide by 2 on both sides. So I divide by 2 and I'm left with cos square of 19 degrees is equal to the square root of 1 minus t squared, 1 added to that, divide by 2. Next step, that is cos square 19. I want cos of 19. So I need to find the square root of 19. Cos of 19 is then equal to plus or minus the square root of a fraction which entails a numerator of the square root of 1 minus t squared plus 1 over 2. But remember, this answer could be plus or minus. But cos of 19 degrees is in the first quadrant. So this answer will definitely be positive. So this is one of your typical level 4 type questions that learners and students generally just leave out in exams. Try not to skip or leave anything. If you do not know your identities, you won't use them. You need to know them all by heart to be able to apply them. In conclusion, thank you for watching. We will definitely see you in our next video. If you liked it, tell your friends. But if you didn't like it but loved it, please share your experience with us. Goodbye.